So, I think I can start, right? I hope. Okay, so good afternoon to everybody. Before I say anything more, is everybody here aware that this is for nuclear engineering? If not, you better leave now, right? Okay, but it's fine. Okay, so everybody knows. So welcome to EPFL, of course, and welcome to our program. So I must say this is probably the biggest class I've ever had. So that's a good sign. I think we have more than 20 people signed up, and that's bigger than we have ever been. So welcome even more so. And I'm very happy to see so many young guys here and people that want to join nuclear. Okay, so I give you the next hour before you leave. This is one of the most important people here in this room, I think. So that is Valerie Scherer, and she is our study secretary and the good, how shall I say, the good soul of our program. Valerie knows everything about the administration of this program. So if you have issues that are non-scientific, she is a much better contact than I am. You can ask me too, but then you get strange answers. So Valerie, but of course we work close together and we always consult. But keep her name in mind. That is an important person here. Will you come back or are you? Right, okay. Okay, so in any case, thank you. Danke, Valerie. Okay, so we also have a few colleagues here from a laboratory. So my name is Andreas Pautz, German nationality, as you can possibly tell by that name. I have been now here at the, I think I should stand in front of the camera. That is, okay. My problem is we are being on Zoom, and if I stand over there, you have an empty camera. Can you? A bit left, you are still on camera. So I'm still on camera because otherwise I'm standing right in front of that thing here. You're still on camera. Really? Yeah. Oh, okay, cool, good. So then I see better. So I'm director of the laboratory here for reactor physics and systems behavior that since 2012, so 10 years now. So you are also and then you should be my 11th class that I welcome here at the school. And my presence here is relatively limited because I'm also director of the Nuclear Energy and Safety Division at the Pautz Institute, which you will also see at some point, so you cannot escape me, right? So wherever you go, I'll be around somewhere. And so what is this master program about? And this morning, I finally replaced my 10-year-old photo with a more recent one. That's me. So I had a 10-year-old photo there. So the two people formally in charge of this program, and it's a combined program of Zurich and Lausanne and PSI, is Annalisa. She couldn't make it today. Professor Manera, she has newly started at ETH Zurich in July last year, but she has been in Switzerland long before, so she is very well aware of the Swiss system. So she just started, and she will be basically your first contact partner in Zurich. While myself, of course, I'm the professor here at EPFL for nuclear engineering, and so I would be obviously I'm your first contact today. So, and we are located at these two wonderful schools at ETH Zurich and EPF Lausanne. And so what should you know? I mean, today I give you a very first brief overview what is going on in this program. And I think what is very important and what we are proud of is that we are actually the first program in Switzerland that happens between the two schools, right? So ETH and EPFL is sometimes a bit complicated relationship, Romandie versus Swiss Allemand and all this, right? And so, but we have managed quite well over the years, so we always stuck together and kept our program going. And I think it was only until 2 years ago that they launched another program, I think in data science, not quite sure, that is also a joint program of the two universities. Of course, important is the synergies with the Pautz Institute. It is the largest research institute in Switzerland. And my division at PSI, Nuclear Energy and Safety. So when I speak of NES is the division I'm responsible for. We speak of 6 laboratories with close to 200 people, scientists and technicians. So it's clearly the largest research entity in Switzerland for nuclear sciences. Yeah, that's why we also call it the National Center of Excellence for Nuclear Energy. And that is an important part of the program, and why I will tell you later. So you are now the 15th batch of students that comes in, my 11th. And so I think we know roughly what we are doing. So you can trust that some things always go wrong. In 11 years, we haven't, you will see that some of you, when you go to ETH and EPFL, there will be glitches. Some, don't be worried, we have always solved them, right? So, but it is the coordination between two schools with overall very different systems is not quite straightforward, just so you know, but usually we are quickly solving those. Yeah, so, and now, of course, what is the issue? If you look at the location of these three schools, the issue is, of course, the distance, right? This morning I came here from Zurich, I live in Zurich, by train from door to door, it's 3 hours, right? So if you go to PSI here, more or less the same. So by car, you are probably 2.5 hours, with traffic or also 4, it depends. And so between Zurich and PSI is 40 kilometers. So you will have to move at some point. Either you still live in Zurich or you have found a room here. But from all what I have seen, our students have managed very graciously over the years to make this move. When next semester you will spend in Zurich, usually Zurich provides you housing from what I know. And then you have to make a decision whether you want to commute every day from Zurich to PSI, whether you want to live somewhere in between here in the middle of nowhere. I live in Zurich, so that's all I'm saying, right? So yeah, and this is PSI, wonderful landscape, but as I said, middle of nowhere. So our division is mostly located here on the east side. Somebody know what this thing is, this big structure? It's not part of PSI, but I'm just wondering. No clue. This is where all the spent fuel and radioactive waste of Switzerland goes to, or is already in. It's the large storage facility, central storage facility for the spent fuel of Switzerland. It looks like part of PSI, but it's not, but we are very, of course, cooperating a lot. So that's PSI. Right, now, the scope of our program is nuclear engineering, and nuclear engineering can mean many things, and I would like to go later here through the group and just see what your focus areas are. Of course, first of all, we are looking at nuclear fission for energy supply, but then, of course, nuclear engineering is also much wider, right? I mean, of course, you can take a look, for example, at nuclear medicine, radiopharmacy, radiation treatments, and so on, and I will give you a few ideas about that later. Also, nuclear fusion. For those of you who are from EPFL, know that we have a large fusion center here, and we are also very open to have students at the fusion center for the master thesis, for example. We also do not want to educate people with a too narrow mind, right? So, I mean, you should be open to the fact that there are other sources of energy than nuclear energy. Not many, I suppose, but I guess there is, of course, renewable energy. And I mean, you also know that Switzerland has an energy strategy that does not necessarily promote nuclear energy, to put it that way. So I think it is important to understand the interplay between energy sources, efficient energy use, storage solutions, and so on. And therefore, I also warmly recommend that you take a class somewhere in that area. And the flexibility is limited, as you will see, but there are interesting classes here at EPFL and at ETH, of course, in that context. And our degree is open to bachelors of a lot of disciplines, so we are very flexible: physics, chemistry, all the engineering disciplines are welcome with us. And the reason is simply that nuclear engineering requires, possibly more than any other kind of energy engineering, a huge amount of interdisciplinarity. And always when people ask me, why do you find nuclear so interesting? This is probably why, because you need something of everything, right? And that makes, I think that makes it actually a really exciting thing, completely regardless of what you think about nuclear overall, but I think that makes it really exciting. Good. So the degree you are here for is, of course, a Master of Science. So that will be a diploma issued with the stamps of both schools. It's not a double diploma, but it carries, of course, the names of both schools. And yeah, and then basically here is your schedule. So first semester would be here in Lausanne. And of course, I will give you an introduction what exactly you have to do in the next few months. Then you would move to Zurich, enter into the second semester. The third semester would be at PSI, and I also tell you how this is organized. And the fourth semester, so basically in a year and a half from now, you make a decision on your master's thesis. And then, of course, you want to have a master's thesis that finds scientific support somewhere. So you want to have a good supervisor for your master's thesis. And of course, I promote PSI or our laboratories in Zurich and Lausanne. So I think for me, the preferred way, and also where I know that a good supervision is guaranteed, would be PSI, right? And EPFL for that matter. We have people, or we had people that did their master's thesis in industry and that worked mostly well, but it's also a risky thing. You might run into a situation, industry people never have time, right? They never have time. So just whatever they tell you, they will never have time. That means supervision is difficult. And if you decide to go elsewhere, you may run into the situations that you are stuck with a supervisor who is simply not there. So if you consider doing your master's thesis somewhere else, please come and talk to me or to Annalisa, and then we discuss and see whether A, it is scientific enough, and B, a good supervision is guaranteed. Because if that is not the case, it's a very frustrating experience. And I have seen that now a few times, that people did their master's thesis with industry and it didn't work too well. So just to be clear about this. We are a tutor-aided program. So I don't know, maybe you have received the message that you should pick a tutor. So the tutor could be, well, first of all, it could be me, of course. It could be Annalisa, of course. It could be also other professors in our program of these guys here. So a tutor is there to basically give you guidance when you have to pick courses, for example, right? So I mean, the decision which master's thesis you are doing, the decision which elective courses you are taking would be something that you should discuss with your tutor. And you don't have to make a decision today for a tutor, but within the next few weeks, you should make a decision whether you would like to stay with me or go with Annalisa. Go, for example, with Professor Tran, which I warmly recommend. He's a fusion guy, has taken great interest in our program. But you could also ask Ambrogio or Mike here whether they would be interested in being your tutor. They really should help you in the course of your studies. And then the people from my laboratory here is most of them are here and sitting in the back row, so you will meet them later. Pavel is here, yeah, so Pavel just is here. So there's Pavel, Matthew is here, Bongsong is here, you saw him there. Carlo will be coming later. Alessandro is not here today. Thomas, I have seen, yep. Eduardo is here, yeah, so Tom, we have several Thomas and Toms here, as you can see. So there's Fanny is not here today. So, okay. So, and then I have also a former student here, Valentin. Probably Valentin just, so Valentin we started together, right? So we started together 2012, he as a student, and he also did his PhD with me. And I guess if anybody knows a lot about the program, it's Valentin. He also has worked with many master students afterwards. So if you want to know the perspective from the student side, he is probably a good person to talk to. And you stick around for a little bit, right? Yes. Yeah, okay, wonderful. Okay, so again, tutors, as I mentioned, Annalisa, there's also Tony Lomax at ETH. If you're interested in nuclear medicine, would be a good person. As I said, Kwang is a special friend. He always comes to this first day to say hi to the students. He has been the head of the Swiss Plasma Center for 2 decades, I think. and he just, this is Kwang. I think the photo is a bit outdated, I must say, but he is retired now, but he takes strong interest in also supervising students. The good thing with him is he has more time now. So if you want to have a supervisor or a tutor who actually has a lot of time, maybe he is a good choice. And I know he is really nice with his students. So, okay. I don't know, maybe I'll stop here for a moment and we just take a, tour de table, and maybe I'm just curious, you know, maybe you can just tell your name and yeah, tell me where you are from, where you have studied before, and maybe why you picked nuclear engineering, what interests you the most. Do you want to make a start? So you sit on the right corner. So.
I'm Reid. I'm from EPFL, and I just finished my physics bachelor.
Yeah.
And yes, I have always been interested in the nuclear engineering. That's why I still learn this bachelor.
So you're interested in nuclear energy from fusion, from fission, or
all?
Okay, that's good, perfect. Good pick then. So okay.
Hi, I'm Augustin. I've also done the bachelor in physics here at EPFL. Yeah, I'm interested in the medical applications of nuclear engineering.
Right.
So yeah, that's why I chose the master because that's the best way to work in that.
I think it is. You know, I think you get a good overview of, or quite a bit to pick from, I think. So also at PSI, I will say a few words later also about the medical applications. Very good. So.
My name is April. I come from Paris, and my interests are in nuclear.
Very good.
Hi, I'm Leonard from France. I also did my bachelor in physics at EPFL, and I'm definitely here for the fission part and plant operation or research and development.
Right. Very good.
I'm Patrick, and I did my physics bachelor at EPH, and I'm most interested in fission or the energy part of this.
I am Luigi, and I'm from Italy. I did my bachelor in Politecnico di Milano in energy engineering, and I'm mainly interested in fission and nuclear energy. I think it's important type of climate change, and I'm still interested also in the integration with the renewable energy and storage. So that's why I'm here.
Does Milano still have a nuclear program, or is it part of the energy engineering program? Or
we have a nuclear program, but in our master.
Right.
So yeah.
Very good. Okay. It's a good program, I know. Yeah.
Hi everyone, same as Luigi, I'm from Milano. My name is Daniele, and I studied energy engineering within the nuclear track. I'm interested both in fission and fusion, actually right now, and we'll make a decision next year.
It's a good place to be. So because we offer both, so that's good. Okay.
Hi everyone, I'm Giuseppe from Italy too. I studied in Politecnico di Torino. My bachelor's name is physics engineering, and now I'm here especially for the fusion part of the program. And
Very good.
I'm Sofia. I'm from Politecnico di Milano. I studied control
It's the Italian block, yes.
engineering, and for my master in nuclear energy, I'd like to focus on medical part, either that or security and safety in power.
Very good.
Hi, I'm Sofia. I'm from Politecnico di Milano.
We have a fan club. We have a fan club there. That's for sure. Yeah.
Bachelor in materials and nanotechnology engineering. I'm interested in quantum physics, and that's why I chose nuclear engineering path for my master. And I'm interested in giving my knowledge in the medical applications of nuclear techniques, but not only.
Okay.
I don't exclude.
No, I mean you have 2 years time or a year and a half time, so that's fine.
I'm Sia. I'm from China, Shanghai. Yeah, maybe most of you heard of this city. Yeah, of course, I did my bachelor in China.
Right.
So, why I chose this program, because I am interested in the medical part. I think it's a profound program.
I know that PSI has a very good reputation for the proton therapy, for example. And I know that actually there are many Chinese students decide to come to the proton therapy also. So you will probably meet a few people there too. Okay.
So I'm Victoria. I have studied mechanical engineering in Athens, and I'm mostly interested in vision and
Right. From NTU, right? National.
yes.
Yeah. We always have a very faithful club of Greek students too. So we have at least every year we have one from NTU consistently, I think, right? Yeah, very good. Welcome.
I'm Guido. I just finished my study in mechanical engineering at ETH. Nuclear engineering, but the whole spectrum of nuclear engineering, but I'm interested in nuclear engineering, but particularly into fusion and nuclear application of technology.
Hi, I'm Nicola. I'm from Ticino. I have a really strong accent, Italian accent. I did my bachelor in mechanical engineering at ETH,
Right.
and I'm interested in nuclear fission.
Right. Good.
Hello, I'm Axel. I'm from ETH. I did my bachelor's in mechanical engineering, and now I want to focus on particle accelerator engineering.
Hi, I'm Pierre. I'm from France. I did my bachelor in mechanical engineering in University of Lausanne. And I'm going to program for the overview of nuclear science.
Right. Very good.
I'm Jean-Baptiste, JB.
JB. Okay. I remember that.
I did my bachelor in physics. I'm interested in the energy aspect of nuclear engineering.
Right.
Hi, I did my bachelor here at TFL in life science and engineering.
Right.
I want to work in
Okay. So very good.
I'm Matis. I did my bachelor at ETH in mechanical engineering, and I'm mostly interested in fusion and fission.
Energy, but energy is the energy part for sure. But yeah, okay.
Hello, I'm Timon. I also did my bachelor in mechanical engineering at ETH, and I'm here for the fission energy, but also the medical applications.
Right. One.
Hello, my name is Lassie. I can like DFA in life sciences.
Second life scientist. Okay, that's good. Okay.
And what I need is mostly new technologies for the energy part and mostly
So a lot of fusion interest going on here, which makes my fusion colleagues happy. But I suppose I can still convince you otherwise. No, I mean, no, of course. I mean, you know, EPFL is particularly strong, of course, in fusion research, and I mean, and that's something also that we should really strongly maintain and expand. And of course, for the efficient part, we of course also need motivated people. So I think for me, both sides are fine, and whatever decision you take in the next years, we will see, right? In any case, so I will continue here. So with now, yeah, thank you anyway. So I mean, that gives me a good first idea. So where the interests are. Now let's take a look at our program. So we have basically, and I will show you in a moment, these mandatory compulsory courses that you must take, right? So they are mandatory, as the name says, and 11 courses overall, and that already covers around 50 of your credits that you need to take. That is a significant part. Now, as you may know, and that is not nuclear engineering, that is not specific, that is in all engineering and science classes, you should take credits that are explicitly non-scientific or non-engineering part, management or humanities. So in order to widen your spectrum a little bit, 4 credits, you can take them in the first or second semester. There is a large course catalog of different classes you can take. I'll show you later. And the decision I basically would leave to you. I mean, this is a huge catalog of different possibilities, but I'll show you in a moment. Then you basically have 20 credits of elective courses. So let's say 5 courses over the next 3 semesters. So you have to pick them wisely. In principle, 8 credits of them you can take for anything you want. which is a master program at EPFL or ETH, but you would need the tutor's agreement unless you take off the approved list of our elective courses, which I will show you in a moment. Then you have to take an internship, that's also mandatory, and how that works I will come back to later. And we also have a semester project, usually in the third semester. That is mandatory, everybody has to do that. And we also offer that you take a look around and talk to people that you think you want to work with. And if you can convince them that you are motivated and sharp and whatever, then you actually can probably work with them on a voluntary basis for another semester project. But the resources are limited, right? So I think this is basically you just take a look around and you talk to people. It's usually first come, first serve, right? So, right. Now, these are the mandatory courses, and I mean, this presentation will be for your download, so you can download this later. And I'm not going to read through this entire list here now, but what you should know is the 3 mandatory courses you have to take this semester. That's physics of nuclear reactors. Well, pretty obvious, right? Because you need to learn what a neutron is and how neutrons behave in a field context, and that holds for fusion and for fission. I mean, there's no, without neutrons, fusion also would not work, right? So, and that is being taught by myself and by Mathieu. Then, of course, you will take part in the radiation reactor experiments. That's our travaux pratiques, as we call it here at EPFL, or our, well, really hands-on on our reactor and different devices that we have in our reactor laboratory. And we will take you there later, so you can take a first look. So Pavel will guide the tour over there, and then next week you will start there with the experiments. Mandatory, so you won't get out of this. Again, it has to do with radiation. I mean, that is everywhere. Whatever you will do in medicine, fusion, fission, it doesn't matter, right? So this is, of course, a very basic course. And then, of course, we also have radiation biology and protection. Again, protection of man and environment from radiation is one of the fundamental ideas of nuclear safety, and that is also a mandatory course. Taught by Pavel and colleagues actually from SCHÜV, here from the Cantonal Hospital. So it's also an option to also make contact with people from our large hospital, which actually has a lot of radiomedicine, nuclear medicine, and so on. The other things you can actually will then happen later. So how to read this table, of course, this is the EPFL block this semester, the credits that belong to the courses. And then, of course, similar for ETH, where you have to be careful here, fuel cycle and waste management, for example, nuclear fuels and materials. And then the third semester happens at PSI. These are listed as ATH courses in the ATH course book, but they are really taught at PSI. So you will not see ETH from the inside in the third semester. And I'll tell you why in a moment. And then you have a fairly long list of elective courses. So before you consider what other topics you might be interested in, you take a look at this list first, right? So these are the courses that we recommend. And of course, I mean, as I said, there's energy conversion and renewable energy taught by a colleague here, François. There you will learn how you can run the Swiss energy system without nuclear energy. Yeah, but it's also the other side, right? So I mean, there you learn about renewables, how do you build a sustainable energy system. Hydraulic turbo machines, if you're an engineer, probably a good thing. Maybe you've heard about it. Image processing, we also look at introduction to medical radiation physics. If you're interested in nuclear medicine, obviously a good pick. Introduction to particle accelerators. One of you said wants to work in particle accelerators. I guess it's a no-brainer then to go to that class, right? And the list continues. Yeah, neutron scattering, theory and applications, nuclear fusion, of course, and plasma physics is still an elective course, but if you are interested in fusion also, obviously, it's a choice to make. So nuclear interactions, this is a new course. This is a colleague from PSI. Yeah, plasma physics is here, radiation detection is here. So again, the blue ones are the ones that are from this semester. So you see, you already have a long list of topics that you can pick from. Yeah, and then of course you can essentially what we call the free electives. But if you only have 20 credits, you should choose wisely, right? Okay, so basically first semester, 3 mandatory courses and the management courses. Second semester, you would have 4 mandatory courses and potentially also this management course. And now you can decide if you feel you have more time in the first semester, which you won't, then you do both management courses in the first semester, or you split, or you do them both in the second semester. I don't care, honestly. But you have to do them, and you should also choose something that's interesting, right? But I'll show you in a moment. Right, now, when it comes to the elective courses, and this is now for this semester, use the next 2 weeks maybe to jump around a little bit. Just take a look at different lectures, at different lecturers, how you like them, because your final decision for the course, you only have to make in, well, basically in 2 weeks from now, right? So you have a chance for the first 2 weeks to change back and forth a little bit. Keep in mind that our exam session will be January 16th to February 4th, so next year. Semester, I think, ends on the 24th of December, so I think it really goes to the last day. Sorry about that, but that is not my decision. If you want to unregister from an exam that you have signed up for, November 25 is the last deadline, is the deadline. And for those of you who do not know Lausanne, who are not from here, don't come here next Monday. It's a holiday, right? I think every year we have at least one person that comes and is surprised that university is empty. So please, Monday is a day off, enjoy it. As a matter of fact, I think in Geneva and in Valais is actually not a day off. It's only here in the Canton Vaud, as far as I know. Okay, and then because it is a mystery, I will explain this magic 4-credit course, these 4 credits in entrepreneurship or management, technology, management of technologies and so on. And this is simply a requirement that you have to take, humanities or management of technology. As I said, you can take them either way at EPFL or ETH, and maybe I'll just jump in there. This long list here is basically, I'm not going to read through this, right? But I just pick a few things. There's, for example, what is it? Digital thinking, I suppose. Real problems, human-focused solutions. Value chain management and practice. Don't ask me what this is about. Global business environment. So, well, if you want to establish your own reactor company, maybe it's a good pick. Corporate strategy, principles of finance. I'm sure there's a bunch of stuff that you can pick from. And I personally, I leave this choice to you, so you can decide. The list goes on, right? So there's more. There's management control, principles of microeconomics. So I think these are all useful topics, but of course you can only take so many. So think about it twice before you commit to one. Looks like a long list, but this is what you really have to do, right? These are the classes that I think are at the heart of the nuclear engineering. Oops, sorry. So this is this one. So these are really, and as I said, you have got these tables later for download. So I have a nicer presentation of this, but I want to point out these are the classes that are really mandatory, these blocks. Physics of nuclear reactors, radiation and reactor experiments, and the radiation biology. So keep that in mind. And the rest is a bit more flexible. And now if you look at your semester, it looks like this, right? It's the first time I do this, I have this table, so because I thought it's nicer to visualize this. So if you think you have lots of flexibility, it's not the case. Many of the time slots are blocked, of course. This one is blocked. This is clearly blocked. This is the reactor class, and these are also blocked. And of course, we have lots of overlap. Many professors may decide to record their class, so in principle you could watch them on Zoom and still attend them. Not my favorite, I must say. We have this unfortunate overlap here between nuclear fusion and radiation biology. We couldn't manage it otherwise. Maybe hopefully you can, the last lesson, the last hour here is not so important, so that you can move to that class. Maybe there's also a Zoom recording. So some conflicts cannot be avoided, but it tells you cannot take everything that is on the list, but is severely restrained, right? Yes.
Isn't the last word exercise?
It is exercise as far as I know. So I guess you can just disappear, right? I mean, it's not ideal. I know that, and I know that Ambrogi will not be very happy about this. But then I guess it is what it is, right? So, but this will actually give you severe restraints on what you can pick. And of course, so if you now look at, let's say, financial engineering, which are also courses you can take, you see they are, of course, all scattered all over the place. But again, most of them will probably collide with something that you also want to pick. Same, of course, with the MTE. There's lots of classes, but again, I guess you just have to pick and choose and then see how it fits into your schedule, right? Little combinatory exercise, not a big deal. You will find something interesting, and up to now that has worked fine. Okay, so that basically gives you an overview what you have to do in the next days and 2 weeks, right? Makes the selection of these classes. Come, of course, to the mandatory classes starting Monday with Pavel, right? Yeah, you teach on Monday afternoon. And then with Matthew and me on Tuesday and Wednesday. It's over 2 days in nuclear reactor class, 6 credits. Second semester, I will not talk much about, that's ETH. You will get an introduction when you come to ETH by Annalisa Manera. So, but I want to just jump into the third semester just to tell you what you have to expect next, because there is some action required from your side. The third semester, summer next year, you have to do an internship, right? 3 months is required. And it should be somewhere, obviously, in a strongly nuclear-related industry. Industry, we are a bit flexible. It can be a hospital too, for example, if you're interested in nuclear medicine. But you have to find an internship position. And we have always managed to put everybody in place. But the last thing I want is actually if somebody comes in May or June next year and tells me, I still don't have anything. Has happened, and we have always managed, but I therefore recommend strongly that you start looking in January of next year, the latest for an internship, maybe even before. We have organized it a bit better now. There is the Swiss Nuclear Forum. It's a kind of a club of the power plants and Nuclear Association of Switzerland. And they are now providing a web page on which I encourage our partners to post their internship positions. And last year it worked quite nicely. I think by March or April, everybody had a position there. Right now it's empty, but it will fill up quickly again. And I hope that there will be something for everybody. I mean, there's obvious locations like the Swiss power plants. You can go to Axpo and Alpic. You can go to the cantonal hospitals or the university hospitals if they have a radiation treatment center, for example. So, as I said, but it's really important that keep this in mind, because if you only start looking for something in May or June, you might be running out of time. Because that would start typically in July. It's July, August, September, right? So 3 months. And in October, you come to PSI. And that is why we organized it in block courses, because we know that you cannot start in September, right? So you have a transition directly from your internship into the next semester, into the PSI block courses. Yeah. And of course, that also needs some preparation, because you probably, if you want to stay at PSI, you should also at some point pick your master's thesis. So typically in May next year, so it's not that far away, we will invite you to PSI, show you the place, and then you also get contact to people that offer interesting master thesis topics. That's our plan. And then within the next few months, you should slowly start thinking, what do I want to do as a master thesis? If you're looking for something outside Switzerland, you are by yourself, right? But if you do that, you will need my approval, otherwise it will not be recognized as a master's thesis. So we need to talk about it if that is being considered. Yeah, so in fourth semester is then the master's thesis, so half year, 25 weeks. And of course, you should ideally have, of course, all your credits, the 90 credits from 3 semesters. You can start with 80. I hope that is not the case. I mean, of course, ideally, you go into the master's thesis and have all the credits cleared, obviously. Okay, so just about PSI. So as I mentioned that at the beginning, that we are basically the one big nuclear research institute in Switzerland. And we are doing a lot of work, and that reaches basically, we have a big hot laboratory. So if you want to learn how to work with radioactive materials, place to go, right? I mean, they do host students. Of course, you need to go through some clearance procedures and so on. But you may have a chance to really work at what we call the hot cells, glove boxes, and so on. So if you're really into radioactivity, that's certainly a good place to go. If you're interested in waste disposal, nuclear waste disposal, of course, we have a large cooperation with NAGRA. And some of you may have heard that Monday this week, NAGRA had officially announced the final site selection, or their site selection for the geological waste disposal. It's a big milestone for Switzerland. And then we have, of course, big facilities. So this is one of the largest test facilities for containment safety that we have at PSI. It's really nice. They really like having students actually at their facility. So that thing is 26 meters tall, and it's like a smaller version of a reactor containment. We do, of course, lots of analytical calculations. So if you are more on the simulation side, you get actually simulate a reactor accident, incident, let's put it that way. Yeah, and of course, we also offer work here at our reactor here at Crocus. So if you want to come back to Lausanne, you are also more than welcome to do your master's thesis in Lausanne. Okay. Yeah, so here you can see again, this is our Panda facility during the construction time, and will not go here another hot cell operation and so on. So we really have quite powerful scientific infrastructure. So, and if you want to work with large facilities, PSI is the place to be. Yeah, but then we have also proton therapy and radiopharmacy at PSI. And as I said, there's quite a few students that actually went that path. So we have the Center for Radiopharmacy at PSI that produces and also discovers new radiopharmaceuticals, does the preclinical testing, so on mice, for example, but then also goes into the clinical phase. And we have a really famous center for proton therapy at PSI, the only treatment center for proton therapy in Switzerland, and for very specific kinds of cancer, like eye cancers, subsurface cancers, and so on, also brain to some extent. So it's really top-notch. Proton therapy is actually one of this method was invented at PSI and has now spread worldwide. So quite a highlight of PSI. Well, of course, and there is nuclear fusion, right? So the Swiss Plasma Center here at EPFL, last semester we had, I think, 3 students that decided to do their master thesis at the fusion, at the tokamak here. Of course, the big goal is make ITER a success, right? So ITER will happen, is in advanced construction status, and then also develop the science that you would then need for the next step, that is demo, right? The demo facility. And what people probably do not know, of course, there's the Lausanne Center, but we also have at PSI, we have the superconductivity test stand for Lausanne, because simply we have more electricity at PSI than in Lausanne. More or less a direct connection to the power plant, to the nuclear power plant, so that helps, right? PSI, I think, I think it's number 5 of the electricity consumers in Switzerland. Okay, there's of course SPV, right, CFF and so on, they need more, but I think we are number 5 somewhere. So it's quite, our machines use, I think, what is our Our annual electricity bill is this year is estimated 25 million. So has gotten quite significantly more expensive now with the crisis going on. But well, okay. So and then of course we have Crocus, our reactor here. It's a nice small device, and it's actually also the last research reactor in Switzerland that we use for education. But you will see we also have a nice, significant research program set up, and my colleagues are of course working on that. We always have PhD students that work on the reactor, and master students. And you will get a glimpse of this later when I'm almost done. So I guess then, yeah. And as I said, for questions, Valerie, you have at least seen now, right? So anything that has to do with administration, she is the one who knows EPFL for so long now, and I'm always struggling. So if you want a correct answer, Valerie is the person to ask. Of course, you can always drop me an email, and then we have some colleagues, Mathieu, Wang Song, Pavel, and Carlo, that will support you here at EPFL. And if you already have questions when it comes to ETH, you write to Professor Manera. Right? So you will have a chance to meet her also here in Lausanne at some point in time already. And well, we have our master nuclear engineering website and so on. So there is some information available. And this thing I will send around later, so at least you have this information. It is without warranty. I'm not quite sure whether I have the latest tables, so please double check. Some course rooms or something might have changed. I'm not quite sure. This is probably a week old or something. Sometimes things change last minute, right? Okay, I think that is all from my side now. Other questions, burning questions right now? It's an honest question, so I mean, this is a chance to ask now. Yes.
To whom should we communicate apart from the tutor the choice?
To Valerie. So I think I mean you can forward that to me. I mean, if you pick me as a tutor anyways, but even if you do not pick me, which I will not be angry. Right? Okay. So as a matter of fact, better don't pick me because no. I'm always a bit torn. Of course, I want to support you as much as possible. On the other hand, I am busy with my division at PSI. So if you write to me, there's a chance that the answer will not come super fast. Annalisa is busy too, but she is working more at the university. So she is, Professor Kwang is wonderful, Professor Tran. He is, as I said, he's retired and he just enjoys working here. And I think he is happy to support you. But please don't get me wrong, of course, if you want to pick me, it's fine. But please put me in CC and Valerie, and then of course the tutor, him or herself. Right, that should be fine. Mm-hmm. Yes.
How do you suggest to divide the ECTS between first, second semester, first and second year? Because like
which the ones for the in general you mean, or
in general, basically during summer,
yeah.
As part of the second year, so
yeah.
Do you suggest to make like 60 credits during the first year, or maybe?
Yes, you should basically try to more or less have the third per semester, because the internship is somewhere in between, right? So you should really, otherwise you will run into trouble. So I mean, if you do only 29 in Lausanne, that's fine, but then you have 31 in Zurich to clear, because afterwards it will be difficult. When you're at PSI, you have not. Yeah. Yeah. Yeah, PSI you will be busy. I mean, the way we set it up is basically that we have these block courses, and they happen basically, I think, 2 to 3 days a week, and in between you are doing your semester project. So you could, in principle, go to Zurich for a lecture, but it seems like a waste of time. So I think the idea really is try to clear the 30 credits each semester, and then you do the 8 over the summer, and then you should be fine. More or less. And you will find that the flexibility is not that great anyways, right? So I guess 2 additional courses this semester and plus these management courses, and then you are done. Mm-hmm. Other questions? Yes.
I know the program isn't built that way, but is it a bad idea to do the internship not in the summer, but during a semester and have like 5 semester master?
I think in principle you can do up to 8 semesters, I think, right? Do I recommend that? No. So, I think it of course it throws you off, right? I mean, so basically what we have been discussing this, and if you actually shift by a semester somewhere, I mean, your master's thesis will be off, of course, which is fine. But if you do your, let's say you would do your, what is the issue here? The issue is basically that ideally you would all start your master's thesis at the same time around February 24, right? 24, yes, 24. And if you shift that now because you take a longer internship or you somewhere, then of course you're off that schedule. And we have basically decided that we only every half year we would accept the end of the master's thesis, right? So that means if you are not managing by August to finish your master's thesis by August or September 24, you would have to wait half a year with your final exam.
So the only possibility would be to have like the 3 semester normal.
Yeah.
And after that, the internship.
That you can do, that you could do in principle, yeah. Because I mean I think that is basically why we also said that we let you in with 80 credits, right? So in principle, 90 minus 8 is 82. So yeah, that would qualify. Yeah? Having said that, I mean, I feel actually once you have done your master's thesis, you probably also want to start a job and earn money. I don't know. So I personally would really recommend that you try to squeeze in it in these summer months. It is tough. The schedule is tough. So I mean, you're finishing the semester end of May, or early June. You will have your exams in June, and then you start working July, so August, September, and then you come back, and then you probably have a 2-week break, and then you start in middle of October. Yeah, middle of October, I think, at PSI, right? Yes.
Okay, I didn't completely understand. You finished the second semester at ETH, and
Yes.
usually the exams are really
Late June, I think, right?
August, September.
Yep. That's ETH. That's right. Yeah, that's correct.
So the internship would be between the end of the semester and the exam, or are those exam
No,
at a different date?
no, Valentin, you know that better than I do.
So the normal ETH examination, as you say, is in August, but most of the nuclear courses have a special exam only in June.
Okay.
So you take all the nuclear courses we discussed here, you will likely only have exams in June and then be done in June. And then from July start your internship and that's it. Maybe one of your courses will have exam in August, but that will be more of an exception from.
Yeah. That is how it works. Right? That's right. Yeah. See, for ETH, I'm a bit shaky too, but you can repeat that in August, September in case you fail, I think, right? So ETH gives you the possibility to repeat in the same period, I think, right?
I'm not sure.
Because you haven't failed, I suppose. Yes. Okay. Okay. Yes.
Are the 8 credits of the compulsory internship in the second semester or the third?
Third. That's third semester. Yes. Yes. Yeah.
Does the internship have to be in Switzerland?
No. If you say you want to go to, let's say, EDF and Electricité de France or something. I mean, we had many people that went elsewhere. We had people going to China, people going to the US. I mean, we do not even expect a report. Usually when you find something, we take a look at this and we say, yeah, that looks like a proper internship. What we would like to avoid, and of course, nothing is super strict, but it should not be a research topic. It should be something that resembles industrial project work. It's always some flexibility, but as soon as you have something, you should come to me or to Annalisa and just talk to us and ask us, look, is this what you expect from us? I will ask sometimes early next year, I will start asking you, so how is your situation? How have you applied? Blah, blah, blah. And then we discuss it, but you can go elsewhere, of course. Yes.
I don't understand what you base your choice of people, like based on what they want to do or what they teach. I haven't seen what you interest in.
Well, if you are interested in fusion, you would probably pick Professor Kwang, Professor Tran. Kwang is his first name. If you're interested in nuclear fission, nuclear safety, you would pick me or Annalisa, I suppose. If you're interested in nuclear medicine, I would recommend Professor Lomax, Tony. He is a professor at ETH and also part of the Proton Therapy Center. So that would be my recommendation, right? I mean, you can also talk to Ambrogio Fasoli. He's head of the Plasma Center now, at least as busy as I am. So I would think he would be happy if you went to Professor Tran, for example. But yeah, more or less. If you're interested in particle accelerators, maybe you can talk to Mike Seidel. He is a new professor for particle accelerators here at EPFL, also a colleague from PSI. I know him well, so also possible. Other questions? Okay, good. So way beyond schedule, I suppose. Whatever, right? So I always run out of time, so that's normal. Yeah, so I would now ask, because we need to organize our reactor class next week, starting next week. Wang Song is in charge of that. We will also take a quick, well, amongst others, all together. Yeah, and you want to show the presentation, right? So then let's just. So it's more than this. Let's see.
So please don't worry, it's a short presentation.
Unlike mine, you mean, yeah? Okay.
I mean, like, it's just organization.
So, no, I want
at some point
to.
we promised you drinks.
There will also be drinks later, so don't worry. Yeah, so we have taken care of that too. Huh?
No, right, okay.
Why?
No, okay.
Okay.
I didn't see you for this. So
Yeah, I just need to find now. Is it not? Do you see the presentation now on the camera or on the Zoom camera or not? It's on Zoom now. Is it? I mean, is it on Zoom or not?
I'll check. Nope, it's
No, it's not, right?
Share. It's not. So this one.
Yeah, that one. That is. I can see. Yeah. Okay. That's on. Okay. Right. And you need the thing here.
Should be all right. Yes. Oh yeah. Okay. My key. Right. And
Okay, so Wang Song is just going to give you the overview of how we are proceeding now, because I mean that needs to be obviously organized. You are the biggest staff that we ever had. So for us, it was a bit of an experience too, how we organize you, and that is also why we had to split it over 2 days. But that is, we will also put you into groups. So, and we said actually that these groups are non-negotiable. We have tried to mix you well. We will not mix you according to your wishes, but we will mix you according to our wishes, just so you know. So you cannot pick your partner, but I think you have the list ready already, right?
Yes. Yep. Thanks, Andreas. So I'm presenting on behalf of also Pavel Mathieu, because we are sharing the class all together. So my name is Vincent. I'm Vincent Lagrand. You'll see me for this class, of course, with Pavel Mathieu, and also if you're taking radiation detection. So I'm part of the team of Andreas, along the colleagues that you see here. And my responsibility is more into experimental research. So here, this is about a short presentation for telling you what you will do next week, because the first class you'll have next Tuesday, for those who are on Tuesday, is experiments. So it's just a bit of organization so that you're not lost. Okay, I know there are plenty of people from EPFL, and possibly from physics, so you know a bit the site, but still. In terms of organization, well, for the class, it's either Tuesday or Wednesday, not both. I mean, if you want to repeat, why not? But okay, it's Tuesday or Wednesday from 8 to 12. And I insist 8 to 12, like be at 8. 8:15 is the start. We'll have 4 groups, actually in the end now of 3, and that's it, not 2 or 3, because we are full with you. You're 24, so it's totally full. And there are 13 experiments to be done. So, well, we have each week, one group has an experiment and moving on week by week. The thing which is important first is that for the
the experiments on Crocus, and there are several, you will be merged to groups at once. So it will be 6 people in the control room. And the oral exam is at the end during the semester. So that's why there are 13 experiments, because the last week is for exams. Okay. So this is the list of the 13 experiments. You see quite quickly that we are starting from the beginning. So I heard that there were some people from life sciences. Please don't worry too much. It will be all right. We'll start with simple stuff. What I mean simple stuff is that we really start with the basics. The first 4 weeks will be just doing rotations between 1, 2, 3, and 4, which are alpha, beta, gamma, and also another experiment on gamma radiation, so that you learn the basics. Okay. And then we'll move on. It will be a bit more complicated. And at the end, you'll say, okay, it's enough. So then about the organization, how we do that is that, well, first thing is at home. read the notice, please. It's helping you a lot. I mean, us, of course, no question about it, but it's helping you. So please read what you'll do. Every morning, there will be a few of us around to help you. So namely, will be in principle 2 per session. Usually it will be Pavel and Julius first, then Thomas Guibaud on Tuesdays, and it will be Thomas and myself on Wednesdays. Actually, it will change a bit because there are some experiments that we are more used to, but okay, that's basically the background, the organization. During the experiments, after the introduction, well, of course, you'll do the experiment, you'll collect data, you'll perform analysis. And again, I insist, you'll perform analysis. If you're leaving the class without the result that you discuss with us, you might be quickly in trouble after. I really recommend that you're ready. So if you've prepared your experiment before coming, then it means that you'll be able to do properly your experiment and then analyze it during the class and discuss it with us at the end. Meaning that when you'll be going home to work in group on your report, you won't be lost because you know that at least your result is fine. Okay. So then, well, of course, before leaving, it's a lab. So you clean the place and, well, then you write your report. It's some work. We know it's some work. Okay. But you're 3 per group, so it should be fine. So about the control area, this will be repeated again and again. And today, just in a minute, because we'll do a quick tour just after to show you the facilities. What's important about the control area? Whoa, masks are mandatory and provided. That's left there. Sorry, my bad. Didn't see that. During summer, we didn't know if we had to keep it or not. So, you know, so it's not mandatory anymore, but we still have some if you want. FFP2. Okay, so feel free to get one if you want. You'll need an access that will grant you. For that, Pavel is preparing a list of everything. So, well, everybody will be able to use his Cabby Pro to enter the facilities. Well, for those who don't know yet, the Cabby Pro, that's the little badge that you'll get for EPFL. And well, then you'll have a dosimeter. We'll tell you more about that, basically a radiation detector. And that will be used during the experiments, and then you'll have to put the dose you got in the logbook. To be honest, no facility, it's pretty much always 0, should be. There's only one class where you could get more, but you should learn not to take. And no, really, it's for radiation protection, you have to learn to play with, I mean, to handle sources, and of course, that requires some practice. All stuff, jackets, etc. In the locker room, that's pretty much the safest place on campus, so don't worry about that. No eating or drinking inside, which is quite obvious. When you have sources, you don't want to lick your hands. But it means also no leaning on the walls, for instance. And well, of course, if you're not around for some time, it's better if you know that you left for a reason. Because if anything happens, like just, I don't know, fire alarm, and then, or just a fire drill, I mean, like, well, we don't know where you are, not cool. You should inform. So that just for first information, you'll get used to it, and this is nothing special there. We are an easy-going facility for that. There are radiation protection rules, and there will be all of that. This presentation, all the rules, no notice, everything will be on the Moodle. So the Moodle page is the web page where you'll get every information you could possibly get.
Everybody familiar here with Moodle?
Not yet.
Everybody has a Moodle.epfl.ch. You actually get access with your password that you have received there. And basically, most lecturers decide to put their materials in the Moodle.
No, I mean, you learn it is just a web page to work with, and we put all the content there. That's also where you will submit your reports. Matthew will tell you more about that after. So for what matters, and I hope that's the last update I did, should be, yes, it is, good. Because we had, Valérie asked you if you had wishes with respect to the day of your experiments. Some of you told Tuesday, some of you told Wednesday, and some of you, the majority of you said nothing. So nothing meant I did what I want. We discussed it with the colleagues just to try to spread a bit languages, stuff like that, you know, because it's if it's only Italian groups and French group, at some point you're not speaking in English, which is no good. No kidding, we're used to it. So it's a bit mixed in terms of, in general, I just assign random numbers, so it's just random. So basically what matters here is that you should be able to find your name here. If you don't find it, it's not good news, tell me. And if you got your name in there, you're either on Tuesday or Wednesday, meaning you're A, B, C, D for Tuesday, A prime, B prime, C prime, and D prime for Wednesday. And here you have the first experiments you'll do. So, well, group A on Tuesday will do experiment 1, which is alpha detection.
Everybody on there.
Missing somebody?
Somebody here who is not on there.
Yeah. No, you found yourself? Nobody's pissed about the day? Okay. Pretty well, I didn't make a mistake, but you know. So in terms of time schedule, again, this will be on Moodle. You can't miss it. Okay. It's the organization of the experiments from the start to the exam, which is the last week. So just before Christmas, that's our way of celebrating. And for the first weeks, as I said, it's just a rotation between the first experiments, which are the easiest. I mean, it's just radiation detection with basics, okay? And then we'll move on with more advanced stuff, neutron detection, and some coincidences, and everything where, everywhere where you find some red, it's because it's an experiment with the reactor, where you are merged in groups. You can see that here it's 10 for these 2 groups, okay? So yeah, that's basically the distribution of the semester. And then I'll just give the rest to hand the presentation to Mathieu, because he'll tell you more about what you will be delighted to hear about, which is how are you evaluated? The fun part. I mean, do you have already questions about the organization or something? Is something unclear? At least for the place, we'll go just after to give you a short tour. Okay, so that yes, yes.
So for Moodle, will be the role of appeal with such the goal.
Maybe you connect to Moodle. Show them.
It's automatic. But there's the group something I will add you during the weekend. So please don't look at now because it might not be ready, but we still need to enroll you in the groups actually. That's the because progress is automatic.
Yeah, and also for the scriptum, you need to be able to read the experiments, and I think the scriptum is on Moodle now.
That's a question we need to ask, actually. We've not printed it for ecological reasons. We used to print it for 20 people, and then we have 10 not used. So if you want a printed version, tell us. Okay. In principle, we don't provide anymore. You have it on Moodle, PDF file, very easy. If you want printed, you just come to us and print a few.
A printed version of what? Sorry?
Of the notice of the experiments.
Manual basically, so the explanations to the experiments.
I mean, it's already more close enough that it would be like.
Let's say because I just realized that you have to read it over the weekend. Okay, under pressure. So let's do Saturday 12 o'clock. Okay, by 12 o'clock Saturday, you will be having access on Moodle and you will have the script there. Because you're supposed to read the first.
Let's be nice with each other and let's be nice with Pavel as well. I mean, for next Tuesday, we know that you might be still processing what's happening. So later that if you've not read it perfectly by Tuesday, It's fine. For those on Wednesday, okay.
And honestly, I mean, on Monday you have a day off. So.
Yeah, let's say because Monday will see me, so if I'm late, it's Monday.
Monday you will come to somebody.
Okay, so just a few words about evaluation, because this is something we have noticed over the past few years. This is the first few weeks. Basically, there was a lot of misunderstanding about what was expected from the report. So here I'm going to show you a few slides about what we expect to see in those reports. And basically, after you're done writing the report, just go to that presentation, check, there are 4 slides. And if you do that, you will have a good grade, guaranteed, okay? Know that basically the first week, one of the report, the one with the lowest grade, will remove it from the average. So that way you have 1 crash test, right? So usually the first week, it's bad. I mean, it's bad, it's not bad, but we discuss the misunderstanding. So we try to clear the misunderstanding once here, after the first week, second time, and usually it runs very well, okay? So it's a mixed evaluation. You're evaluated on the report you do on a weekly basis, and there is an oral examination. The oral examination is a 20-minute period where you have 0 preparation time. You just pick randomly questions, and we basically discuss. It's usually about what happened during the lab, some experiments we pick randomly, and then you tell us what you've done and how you did it and what was the purpose and so on and so forth. For the reports, they have to be unloaded 1 per group on Moodle. And because we have 2 sessions, so Tuesday, Wednesday, we give you the same amount of time, so 5 days. So if you go on Tuesday, you need to submit your report by Sunday night. Okay, if you go Wednesday, it's Monday night. Then I grade, and then come back, I give you the corrected report the next day. So that means that before the next experiments, you have the corrected report. And then I come in the lab and we can discuss it. Okay, if something is unclear, you disagree with the grade, then we can, I can do a bit of explanation. That's what it is. And then those are the 4 slides where I discuss a bit the main things to do. First of all, conciseness. Please keep it below 10 pages. Okay, you're not graded by the weight of that report. And also, basically the idea is not don't copy paste whatever is in the scriptum. All right, I'm expecting your own words. I've written my words so many times. Please use your own word. And when you do, proofread yourself afterwards. I mean, in there you have some example of funny stuff we see year in, year out. I mean, again, proofreading, it makes sense. And this is good for you afterwards. If you stay in academia, then you get to write reports. I mean, you need to know how to do this. And this is a bit of a training for that. Then, number of significant digit, uncertainty. I mean, this is a bit of a standard practices when you do experiments. Again, here you have some example of good thing and bad thing, and I will pay attention to this. So please look into this. If you don't understand what's written on that slide, please come talk to me and we will discuss the matter. I mean, you guys have done experiments before, you have written reports, so this should be standard procedure. Okay, if it's not, then we can discuss it, no problem. Axes, captions. I mean, it seems trivial, right? I mean, duh. You should know this, you should do this, but look, it happens again. First few weeks, you will see that sort of plot and we discuss it. And then, one of the main things, this is a scientific report. At the end, you will have a measurement that would be that that gray dot on that graph. And then you have a reference value, we'll give you in red. And after your measurements, it's 11 a.m. on Tuesday, you want to go out for lunch, but you still to have a conclusion there. Is it a good agreement, a bad agreement, that sort of thing. Right, so please conclude when you do a report. And you can only conclude if you have an uncertainty. Yes, it agrees within the reference. No, it doesn't agree because this, and that. Again, those 4 slides, they will be on Moodle. Every time you write a report, read those slides, check, you do this, and you'll get a 6 guarantee. And this is it. Okay, so now I think we're done with that and we go to Crocus to visit the beast. Okay, thank you.